Okay, you're our go.
Hello, my name is Ashley Forey. I am coming to you from the great state of Minnesota. I am here to talk to you guys about our high school engineering by design courses that we offer through our STEM Center through ITEEA. My role with ITEA is I'm the instructional manager, writing, developing, creating curriculum, as well as delivering professional development trainings in the courses that you're about to see, not only for high school, but elementary, middle school. You also get to enjoy educator. I am a 6th through 8th grade technology and engineering educator here in Minnesota. I am on my 15th year of teaching our middle school age students. And I have taught high school periodically throughout my 15 years, depending on if there was a need for me to move into that building. My areas of concentration are all over the board, of course, from woodshop to CAD engineering to electricity, robotics, digital art, app creations, you name it, I probably have taught it. So welcome to our virtual conference. Let me know if you have any questions along the way. Otherwise, I will do a question and answer at the end, but let's get started. So I'm going to begin with who are we? The STEM Center. The STEM Center for Teaching and Learning was established in 1998 to strengthen professional development and advance technological literacy. Center initiatives and directed towards 4 goals: develop the standard-based curricula, teach enhancement, researching concerning teaching and learning, and curriculum implementation and diffusion. Our standard-based curricula, our engineering by design, or EbD is the abbreviation, believes in unlocking children's untapped potential to shape future technologists, inventors, designers, and engineers. Our curricula inspires students to embrace challenges, learn from failures, and persist in problem solving. Teachers guide students to see effort as they pass the mastery, especially through initiative engineering process. So why EBD? It incorporates active learning strategies. EBD curricula engages students in hands-on, project-based activities that encourage collaboration, critical thinking, and creativity. It encourages teachers to use inquiry-based learning, where students explore and solve real-world problems using an engineering design processes. Differentiates instruction. EBD curricula supports teachers in adapting lessons to meet the diverse needs of students across all grade levels. It provides scaffolding techniques and flexible assessment tools to accommodate different learning styles and abilities, ensuring accessibility for all students. It also integrates our cross-curricular connections. EBD curricula emphasizes on the importance of linking integrative STEM concepts to other subjects like math, science, and literacy. It helps students deliver lessons to demonstrate how STEM knowledge applies in various fields, fostering interdisciplinary understanding and applications. We are also aligned or have standard alignment. EBD offers the premier standard-based curricula module designed to be flexible, affordable, and accountable. The pre-engineering curricula is based on the standards of technological energy and energy engineering literacy, as well as other national standards. We pride ourselves at using the standards for the next generation science standards, our Common Core math standards, our Common Core English standards, and our NEA grand challenges for engineering. Our curricula delivery has various options. We have a media-rich curricula, which is delivered through a platform we use called Buzz. It's our LMS system, which we will actually look at here in a little bit. It also contains embedded pre and post assessments, videos, teacher PowerPoint presentations, adding that in there, and can be ported to other LMS systems within your district using a feature that we have called Publish Anywhere. So if you have a school district that uses the LMS system of Canvas or Schoology, our curriculum is able to be delivered to your platform. We also have standard editions available for our consortium states. Curriculum is delivered by PDF files and hyperlinks to the resources. So, how does our curriculum look? Well, our curriculum actually scaffolds from pre-K all the way up through 12th grade in a variety of different areas. In our elementary, we begin exploring STEM through our 20 lessons that are provided to dig deeper into engineering aspects, beginning with preschool. Each of the activities for elementary feature engineering-driven activities, design, the engineering design process, literacy incorporation of vocabulary and spelling, math practices. Wow, it just changed automatically on its own. There we go. Math practices, presentation skills, community connection opportunities, and many more. Once our students advance out of elementary school, we also have a curriculum which is related to our middle school. Our middle school curriculum features for 6th through 8th graders begins with a first 5-day lesson. It's followed by 4 knowledge and skill building KSB units. And in each side of each of those KSB units is 5 lessons, the preliminary challenge, and a primary challenge. Our high school curriculum from 9th grade through 12th grade, which is what we are all here to hear about, begins with, again, those first 5-day lessons, followed by 3, 4, or 5 learning cycles, depending on what courseware you're teaching. Inside each of the learning cycles, there are 5 lessons, a primary and a preliminary challenge. We also pride ourselves of using our 6E Engineering by Design information for delivering our lesson plans. The 6E Engineering by Design model offers the systematic approach for integrating the T and E of the STEM into classrooms, unifying design and inquiry to enhance both technological literacy and the next generation science standards. E stands for engage. It piques students' interest and involves them in the lesson while assessing prior understanding. Explore allows students to construct their own understanding of a topic. Explain provides an opportunity for students to explain and refine their learning. Engineer deepens the understanding by applying concepts to the design world. Enrich enables students to explore concepts in more depth and apply them to the complex problems. And evaluate helps both students and teacher assess learning and understanding. Now, you probably noticed the E on engineer is little because we at ITEA believe every person, every student, every individual can engineer. Our high school curriculum immerses our students in comprehensive STEM education covering technological concepts and processes, programming and computer science, and engineering technological literacy. Students engage in creative and innovative activities, explore standardized fields like cybersecurity, biotechnology, and robotics, and develop problem-solving skills through sophisticated engineering design tasks. It includes modeling, assembly, and engineering design challenges, preparing students for certification exams, and fostering collaboration design skills. It equips students with the essential STEM knowledge and inspires them to lead and innovate in a technological world. Majority of our courses, unless it's a certification, is a 36-week course, meaning a semester-long duration. So let's break down these courses. Our first course that we have here for you is our certification course that we have. It is our Onshape Certification by Design. This course is broken down into 3 units that have 5 learning cycles, a primary and a preliminary, Students will complete modeling, assembly, and engineering design challenges and will have the opportunity to work collaboratively while designing their own parts and assemblies. These challenges actually will provide students with the practice, and some challenges will emulate the Onshape Associate Certification exam. Coming soon, like 2025, very soon, almost here, is a Rec Foundation Pre-Engineering Certification by Design. The Engineering by Design Industrial Certification pathway will soon be offering a high school course in pre-engineering and robotics. This 18-week course will cover robotics, aerospace, chemical, civil, and electrical engineering, as well as computer science programming and manufacturing technology. Students will master the skills needed to take the Rec Foundations certification exam and become an industrial certified before graduation. So this course is going to be coming, like I said, winter of 2025. Nope, take that back, not winter. Well, it is winter, it's January. January, February of 2025. You will see flyers coming very soon. We also have our computer science class. This is our AP Computer Science Principles by Design. It is our NSF funded courseware. This course is organized using a College Board AP Science, Computer Science, Big Ideas, and computeral thinking practices. In this course, high school students program using SNAP programming language, learn some of the most powerful ideas of computer science, demonstrate creativity, and discuss the social implications of computing, thinking deeply about how they can personally be active in promoting and reducing the possible harms. Ninth grade course is our Foundation of Technology and Engineering. This prepares students to understand and apply the technological concepts and processes that are the cornerstone for the high school technology and engineering program. Group of individual activities engage in the creating ideas, developing innovations, and engineering practical solutions. Technology and engineering content resources are laboratory, classroom activities to apply student applications of science, mathematics, and other school subjects in authentic situations. Our 10th through 12th grade course. Students take technical design. Students in engineering teams apply STEM concepts to solve or in skills to solve engineering design problems and innovate designs. Students research, develop, test, and analyze engineering design using criteria such as design effectiveness, public safety, human factors, and ethics. Our 11th and 12th grade courses are advanced design applications, where students will focus on three-dimensional of technological literacy, knowledge, ways of thinking and acting, and capabilities, with the goal of student developing the characteristics of technologically literate citizens. This course employs teaching, learning strategies, and enables students to explore and deepen their understanding of big ideas regarding technology and makes use of a variety of assessment instruments to reveal the extent of understanding. The other course for 11th through 12th grade is Advanced Technological Applications. In the Advanced Applications course, students explore 5 key areas: engineering, design, graphics, cybersecurity, biotechnology, information technology, and robotics. They learn technical graphics and engineering design process and sketching. Cybersecurity covers online safety and ethical behavior. Biotechnology examines the impact of organisms on industries, enhancing biotechnology literacy. And information technology teaches data analysis and 3D modeling. In robotics, students code and build a soft robot for practical application like home automation and assisted devices. The 12th grade course, our capstone course, is called Engineering Design. This course focuses on how engineers apply their creativity, resourcefulness, mathematical, scientific and technological knowledge and skills in the creation or refinement of technological products and systems. A key approach will be to employ the sophisticated sequential and initiative design and develop process to solve authentic engineering task problems. So let's look at our curriculum through our platform of Buzz. Yes, you probably thought this was going to totally just be a PowerPoint. Oh no, we are going to do a deep dive. So what you see before you, let me make it bigger. My small eyes here, is all of the courses from elementary all the way up through high school if you were to have the whole Buzzline collection for your schools. What we are going to begin with is that look at Onshape, which was our certification course that we have up and running, working in our school districts for us, and it's our certification design course. So all of our courses are very much laid out the same way, same feel. So when you have multiple preps, as we do as technology education teachers, you don't feel lost because the modules look completely different. They are all exactly the same laid out. So as you get comfortable with using the LMS system of Buzz, you will get comfortable not only with your content, but where things are located. So the course introduction gives you the overview of the whole entire course as a teacher, how to navigate on Buzz, as well as the standards and benchmarks that are required for our curriculum. All of our courses for high school as well as middle school begin with these first 5-day activities. This is where you get to learn your students, what their knowledge is that they come from or come with, their past experiences, but also working on building, relationships and having activities that are incorporated. In Onshape Certification by Design, it begins with what is an orthographic image, what is an isometric image. Then it breaks down into what is engineering drawings. Your students make a title block on day 4, and on day 5, they're doing their first presentation of how they basically reinvented, or I should say innovated is the correct word, can something that they have experienced and seen before. You also get to see your students' growth in basic pencil paper sketchings to again learn the concepts that they have from prior knowledge in years past. Okay. So the next unit goes into sketching and features. This is again linked to the Onshape certification exam. If you're not familiar with Onshape, Onshape is a program, a company like Autodesk, Inventor, SolidWorks, but they are iCloud based. So this curriculum is to not only learn their program of Onshape, but also to get a certification, an industrial certification through their company. So the first learning cycle is on sketching geometric constraints and using Onshape. Or I should say the first unit, which is then again broken into all of these sub lessons. Each lesson is about a week long, 4 days, and then on Friday-ish, depending on if you're Monday through Friday, would be like your project's due, let's review it, let's assess it, kind of criteria. Inside a learning cycle, you're provided with the overview. You're provided with your lesson plan of the 6 E's. Let's take a look at this. The 6E breakdown. So here's your big idea, your learning targets, all the resources your students need, all the resources you need as a teacher. There's videos in here to help you if you can't remember how to do something to support you as an educator. You have all the vocabulary, and then you have the breakdown. Here's the engagement. Here's the exploration with a PowerPoint. We also have everything recorded on Onshape, so it could be flipped classroom style, or if you have that kid that's absent, here, go watch this video so you can catch back up. We have explain, engineer, enrich, evaluate, all your assessments, everything you need to be a um, fully supported course in the classroom. Okay, so this is Onshape. This is the look of Onshape. Comes with a pre-test. Again, you have videos to help you through the information and the data in the classroom. This is also a cohort course that usually runs in the spring, where teachers can sign up and join to get professional development training and learning, to experience Onshape for yourself. So we also do the training behind our courseware, so you can feel fully prepared when you enter the classroom with your high school student. The other course that was mentioned, Certification by Design, is in writing right now. It's being written right now. It is our pre-engineering in robotics course. It will be working with the Rec Foundation, so I can put this in here, which some of you may be familiar with. They are supported by VEX and our robot company of VEX, the robotic company of VEX First Engineering. They house all the competitions in um, the robotics, yeah, it's robotic competitions. So they also have a certification. They actually have two of them, one in pre-engineering and one in robotics. So the new course that is coming is to help support our students in the classroom with getting their industrial standard from the Rec Foundation. So you'll have to stay tuned and watch ITEA's announcements and launches for that courseware and the professional development training that will be coming with that. Um, the other course that was in that line went to our 9th grade course, which was the Foundation of Technology and Engineering. So again, when we open up this activity, again, you will see that it is laid out with your home and your resources. This has a little bit more structural resources than just what Onshape requires. More safety guideline videos are embedded in here because you're not just using a CAD computer program. You also have the welcome letter from EbD. And then, of course, you have your outline, your blueprint materials, all the references that you need for in the classroom, because this one will consist of having materials on hand to build with. This course also allows you to begin the Onshape by Design Associate's exam pathway, or we also have the opportunity to do our Autodesk or AutoCAD certification pathway. And what this means is that in our curriculum, see if I can make this file work. Yes, we have embedded a 3-year course cycle as well as a 1-year course cycle with Onshape and or with Autodesk. If you choose to teach the Onshape course, it's an 18-week long course, so it could be just one semester standalone course duration for you. And you could probably even condense it down a little bit shorter, depending on if you need more time or not. 18 weeks is, about a semester if you think about it. Or you could teach 1 unit in Foundations of Technology and Engineering, 1 unit in Technological Design, and then 1 unit in Engineering Design. And so over the course of 3 years, they scaffold their learning in Onshape, and at the end of the 3 years are able to do the certification exam. And the same thing applies with the Autodesk. So that is an option as well with our courseware from EbD. So again, it begins with the first 5 days activity. Get to know your kids, get to learn their thinking. You have your lesson plans, you have your support files. They're working together in pairs. This one is them collaborating to make a balloon slingshot activity, because we all know that we like problem solving activities to start off our academic year or semester with our students. Spiro is a company that also is housed in Foundations of Technology. We also use Microbit, so we have two different ways to do the computer science principles. We are then, after we do computer science, we move into the process of engineering design. Our design world is talking about their, I think this is their dream bedroom design, if I'm remembering correctly. And they're going to create a dream house and bedroom world. We also have our systems of engineering curriculum, and then we go into our CAD foundation with your different options of either using Autodesk or using Onshape. So there's pre-assessments, post-assessments in all of our Buzz platforms. This is the 9th grade semester long course, Foundations of Technology and Engineering. The next course that was mentioned in that list was the next 11th and 12th grade course, which is technological design. There it is. Had to find the beautiful picture. So this is the 9th and 10th grade course. And again, you see your first 5 days. You see that Onshape is put in here. Now, we have Unit 1 and 2 in here because depending on how your school scaffolds your learning, you may end up getting students that have never done Unit 1 and want to take the Onshape certification exam, and they're 11th and 12th grader. So you would start them at Unit 1 and progress them to Unit 2. All the information's there. But that is a beautiful feature, like I said, for being able to incorporate that Onshape certification through the 3 different years. This course focuses on engineering graphics, design fundamentals. We also have our technological skills, which brings in our robotics. We have our technology and the society and how we impact, our inventions impact our world. And then we also have emerging technologies, which is focusing on photography, augmentation, wearable technology and design, virtual reality, and the premises of these new emerging technologies of our 21st century. After that, the third capstone of your students would be going to the home key, there we go, would be our engineering design course. There it is. And again, this one comes with the first 5 days activity. Now you have units 1, 2, and 3 for Onshape. Again, if you have students that jump in or move at different times or come into a course where you are able to continue that certification for Onshape. This one focuses on the fundamental of engineering design, the elements of design, and we have our structural bridge work design, civil engineering, and then project management, assessment or activities of, how to control or how to work in project management assembly style. So this is that 12th grade course or 11th, 12th grade course, the capstone course for that 3-year cycle path. Now, we also have for our other classes that we can throw in or utilize or add to, because if you think about it, each one of those classes are only a semester. I have students who at the next semester will want to change into another course. So I introduced to you technological design. We also have advanced technological design. So your students would go from maybe first semester technological design and then take this one second semester. This is where our students get to work with design graphics and spatial skills. Cybersecurity, this is the biotechnology, information technology, and robotics with a soft robot that your students will be able to encompass and engage into for additional, I guess, tech ed support with tech ed and engineering support with the next semester. Another advanced course that we have is our design applications course. This is working with more of the trades, the construction, the power and engineering, transportation, manufacturing. We also have utilized Perch, which is building and creating a device or contraption that actually utilizes your swimming pool. And then we have epics that we've included challenges from, as well as material science for a submental unit in our advanced design applications course. The other course that was also mentioned on that list was our computer science principles by design. This is an introduction to programming and how computers work and how the internet works, as well as, data structures, algorithms, simulators, where students do coding using a SNAP program, which is drop block coding. This is also part of our Excite program that we are initiating across the nation. You may have seen the flyers from ITEA, Excite 2, Excite 2. So we have 11 states at the end of this year that will be on board with this computer principles by design course. And we are hoping to add more and have more in schools. Computer science is definitely a growing industry, and we are very proud to offer it at ITEA. So there's the inside look of Buzz. Like I said, this is all of the courses that from pre-K all the way up through high school. And let's go back to our PowerPoint because we have some more slides and information for you. All right, let's see. The black screen of thinking. Well, we left off right here. All right, let's see if I can. I was gonna see if it was gonna let me jump up, but it didn't let me jump. So let me go through quickly where we left off. Like the dead air time. Okay, come on. Almost there. There we go. All right, so couple implementation strategies. Our curriculum integrates or integrated EbD into existing engineering technology education STEM program or starts a new one. We have aligned our entire curriculum to standards linked below, which creates a seamless STEM learning experience that complements other subjects. Professional learning ensures that teachers receive comprehensive training on the EbD curriculum and STEM teaching methods. This can include an in-person or virtual training, just-in-time mentoring, and or asynchronous courseware. The annual ITEA virtual and in-person conferences also provide great learning opportunities as well for you to experience some professional learning. Resources allocations are to provide the necessary resources such as materials for hands-on projects, technology and engineering equipment, and access to labs or makerspaces. This supports the practical application of STEM concepts. Collaborative learning. Foster collaborative learning environment where students can work in teams to solve real-world problems. This encourages critical thinking, creativity, and communication skills. Our implementation strategies go a little bit further. We also have community partnerships to establish partnerships with local businesses, university, and STEM organizations. These partnerships can provide additional resources, mentorship opportunities, and real-world insights. We also have continuous assessment, implementation, continuous assessment methods to monitor students' progress or adjust the program as needed. This can include project-based assessments, student portfolios, and regular-based sessions. And parental involvement. Engage parents by informing them about the goals and benefits of the EBD. Encourage their involvement in projects and school events to create a supportive learning community. So, as I was explaining, our professional learning comes to us in various forms. We have in person training where school districts, teachers, state directors can reach out to us and say, hey, we would like to implement foundations of technology and engineering in our ninth grade course. Um, that can be arranged, set up. We have trainers that would be sent out to you to deliver an in-person training session. And the duration there are multiple models for the duration that could be delivered. It could be a couple days, a couple weeks, or not a couple weeks, but a couple days, a whole week. It could be a couple days, a week for multiple durations through a month. Like everything can be arranged. We also have virtual training offerings depending on our courseware. There are many different ways that we can do a virtual training for our courseware. Mentoring, just in time support. We all have those lovely teachers who join us at the last moment of the school year. And we do offer and will help support mentoring through our curriculum with those teachers. And then we also have asynchronous learning, which means that you could take a course and have video support to guide you through the whole thing. We have a few courses that are able to operate that way. That few course that is able to operate that way is our Onshape Certification course. It is a self-paced course that includes 3 units, 5 learning cycles, 2 challenges. The educator uses Onshape, an ITEEA Buzz learning platform, to complete the activities and submit a portfolio for review to receive a certificate of completion. This course is ideal for educators wanting to use Onshape in their classrooms, teach it to students, learn about the Certified Associate exam, and also become certified yourself. It can be started anytime and completed in about 40 hours of your convenience. And you also have graduate credits that are available for you at an additional fee. The QR code that is linked on this will bring you to our ITEEA website, which will allow you to sign up for this courseware. We currently have across our nation, I believe instructors who have started the course when it launched in August. The end of August is when it went live. So feel free to hop on, join us. It is completely at your own pace. We have some educators who are already on Unit 2. We have some educators that are signed up and waiting for winter break. But it is 40 hours videos at your own convenience, and you will practice and learn how to do Onshape just as if you were a student yourself sitting in your class. So it's a great professional learning opportunity for our busy schedules we have. Like I stated, we also have grad credits that are available for many of our professional development learning sessions. Whether they're in person, virtual, or asynchronous, St. Cloud State University here in Minnesota recognizes that ITEEA curriculum is very credible, and they have decided to partner with us to offer our teachers and our instructors who receive training from us the chance to receive some grad credits from their university. That is $500. That's the charge for 3 semester credits. There is no application fee. You register as a non-degree seeking student unless you want to utilize their technology and education master degree program that they offer. And that is available for again, your in-person, virtual, and asynchronous professional developments from ITEEA pairing with St. Cloud State University. Coming soon are some more asynchronous professional learning opportunities. Rec Pre-Engineering Certification by Design will eventually become a synchronous learning style. We have Engineering Tech Ed Lab Safety by Design, which is in development. Learning by Evaluating by Design, Soft Robotics by Design, STEM Methods by Design, and many more courseware is going to be in development and coming soon to you. We also are very proud of our research from our ITEA lens. We have the NSF POSE grant that is supporting ITEA to create an educational CAD library for K through 12 schools. It is https://cadlibrary.org. It is up and running. There are great resources of activities that you could incorporate in your classroom. This library extends peer reviews to CAD models and encourage design alignment with K through 12 standards. Unlike the repositories for the focus of K-12 education and requires peer review on all models. So you will see some activities in there that have been brought up by educators across the nation that they have a great idea, they want your support, they want your review on it, and then that research will be used for future curriculum development and or lessons for you to incorporate into your classroom. We also have DRK-12, Learning by Evaluating, which is preparing students for the design work by enhancing their critical thinking and ability to justify ideas. Students are to compare pairs of previous work to identify which one is better and explain their reasoning. The teacher-led debrief helps them recognize quality patterns, initializing expectations of their own work. This method was developed collaboratively by Purdue, UGA, BYU, and ITEA, and is funded by the National Science Foundation. The Excite 2, this was the course that I was telling you about, our computer science principles course. Project Excite 2 is exploring computation instructional into technology and engineering. It is an SFS funded partnership led by ITEA in conjunction with Hofstra and North Carolina State University to develop a professional development and implementation support program to help prepare the nation's high school technology and engineering teachers to teach a College Board Advanced Placement Level Year 1 Computer Science Principles course. Right now, we are seeking educators from North Carolina, New Jersey, Georgia, Pennsylvania, Delaware, Idaho, Kentucky, Minnesota, Missouri, I believe is MO, and I think there's a couple other states that we actually piloted for cohort 1, but right now cohort 2 is open to those states. And that QR code will bring you to the Excite 2 website to sign up. The Excite 2 cohort is funded, fully funded. So they are looking for teachers in those following states to help fund your computer science course, get you set up, get you rolling into the computer science, provide you training, and experience computer science principles by design. So that QR code, this is a summer training session for cohort 1, or for cohort 2. Cohort 1 finished last summer. Curriculum implementation and diffusion. Curricula professionals learning and research systematically meshes. Our curriculum is also authored by field experts and piloted in STEM classrooms. So one of the things we really pride ourselves with at ITEA is that our curriculum is developed by teachers who are currently teaching. We also have the pride that we are able to use our students in STEM classrooms to take our lessons, pilot our lessons, and give us feedback on what went well, what didn't work well, what was too hard, what do we find that we liked, and actually get a true sense from our students' perspective besides our educators' perspective in our curriculum. If you haven't received a lot of emails lately, we also want to take this moment to let you know that our STEM School of Excellence awards program is running right now. ITEEA STEM Center annually recognizes outstanding schools for their commitment to providing a robust integrative STEM education experience through STEM Schools of Excellence recognition program. All K through 12 schools, colleges, and universities are eligible to apply. They extended the date of submission to December. I think it's December 6th now, if I'm remembering off the top of my head. But that QR code will bring you to our award platform to fill out for your school to get yourself awarded for our STEM School of Excellence. We present our awards at our in-person conference that is happening in April. We also have our Reach Challenge that is up and running as well. Our Reach Challenge is an impactful, adaptive, and assistive technology design thinking project for middle school, high school, and college STEM programs, showcasing ITEA's mission that technology and engineering bring STEM to life. Teachers are provided with a toolkit of curriculum and resources to lead their students to create a viable, adaptive, and assistive technological solution to help someone in their community. Projects can be submitted to ITEA for the opportunity to be awarded and funding for their STEM program. That QR code, that's bright red, will be able to give you all the information that you need on that Reach Challenge. This form QR code, if you can take a moment to snap a picture, is for any requests that you may have on your learning today from our high school curriculum, or if something from elementary or middle school excited your knowledge, but anything that you would like more information on from our STEM Center. This quick Google form will allow us to reach out to you and help answer any questions that may come up after our session today. And or that you still have wondering from our session today. A few other little factors. This QR code will bring you to our ITEA website, which I'll show you here in just a moment to round off our ending of our presentation. But our director, STEM director, Mark Pearl, is in our office for you. There is his email contact as well as his phone number. And again, I am Ashley Forey. I am the STEM CTL instructional manager. My information is also provided for you on this slide, as well as my contact phone number. If any questions come up or any concerns, or you need to get a hold of us, we are here for you. We appreciate you guys as educators. We know how the school year is going, and we want to make sure that you have educational resources for you when you need it. At our STEM Center, if you go onto our ITEA website, click on our STEM Centers tab, you can also dig into your own findings and your own information. Our Engineering by Design program has our code descriptions information here provided for you. A lot of the things that you saw in the PowerPoint presentation are listed here for you as well. Our professional learning, our research. If you were wondering if you were a consortium state or not, that will be the state by state. The states that are in red have an association or consortium association affiliation with them. If they have a star, the red are fully consortium states, and non-consortium states at this time are in blue. Consortium or not, our curriculum is for everyone. And so let us know how we can get some STEM skills out to you. Since there are no questions at this time, I'm going to finish our session. Thank you so much for watching, and We hope to have a great rest of your year and let us know how we can help.